Hello everyone. We have the following question on inclined surfaces, where you have two masses connected passing through a frictionless pulley, and you are given the direction and the magnitude of the acceleration, the angle, the coefficient of kinetic friction between M2 and the surface, M1 value, and you're asked to find M2. So let's start by recording what we are given here. We have M1, the angle of the incline. We are given the coefficient of kinetic friction, 0.250, the acceleration of the system, meter per second squared, and we are asked to find M2. So this is the unknown. All right, so let's start by applying Newton's law on both masses. We'll get two equations, and then from those two equations, let's see if we can solve for M2. So first thing, let's look at the forces acting on both M1 and M2. And we'll take, if we start with M1, this is the force body diagram. Now recall, regarding to forces, we have the force of weight, we have the normal force when the object is laying on a surface. We have the friction if the object also is on a surface and there is friction between the object and that surface. There is the force of tension when there is a string connected to the object, and there is also any external or applied force that might be acting on the object. There is also the force of electricity and magnetism, which we will cover in physics 2. But for now, those are the forces. The applied force could be any force, pull, push, any type of external force applied on the object. Now for M1, we have the force of the weight. On the force body diagram, we'll draw M1 here as a point mass, and we'll record here the forces acting on it. So we have M1G downward. There is no normal force applied on M1 because it's not laying on a surface. Friction, the same thing. There is no friction on M1. It's not laying on a surface. Tension, yes, there is a force of tension upward. The force of tension is always directed from the object toward the rope. So it will be upward here. This is the force of tension. So I'll write it here. Okay, so those are the forces acting on M1, and we know that the direction of the acceleration is downward. So we'll keep that in mind. Okay, now let's look at M2. What are the forces acting on M2? We have the weight of M2, which is directed downward. Its extension will be perpendicular on the surface. So this is M2G, the weight of M2. There is also normal force, yes, and the normal force is always perpendicular on the surface toward the object, so it will be in this direction. That's the normal force. It's perpendicular, of course, here. We draw its extension. It's perpendicular on the surface. That's the normal force. And this angle here between M2G and the normal force is equal to this angle. Okay, this is also 30. If you think about it, if this is 30, this is 90, this angle here will be 60, and since the whole angle here is 90, then this angle will be also 30. So this angle is equal to this angle. Okay, what other forces here? There is the force of friction, which will be always opposing the motion. Since the motion is upward, then the force of friction on M2 will be downward. So this will be the direction of the force of kinetic friction. Do we have tension? Yes, we have force of tension as well. So again, I'm going through the forces here, force by force, to look at what are the forces acting on M2. So we have the force of tension, and there are no applied forces on either M1 or M2. So those are the four forces acting on M2. Now the second step here is to resolve those forces into components. And for inclined surface, as we learned, we'll take the x-axis to be lined up with the surface. So this will be positive x here, negative x, while the y-axis will be, of course, perpendicular as always on the x-axis. So this is positive y, this is negative y. So here for M2, we can resolve M2G into two components. There will be M2G cosine theta, and this will be lined up with a normal force. and there will be m2g sine theta, which will be lined up with the friction force. So this is m2g sine theta. And we can replace m2g by its two components. So now I can go ahead and delete m2g since I replaced it by its two components. So now if we draw the force body diagram for M2, and I'm going to draw it upright, I don't need to draw it as an incline, but you should know that we took the x-axis lined up with the incline. So now we know the forces acting on M2 is the normal force lined up with the positive y, mg cosine theta downward lined up with the negative y-axis. Then we have the force of tension in the negative x direction, while the force of friction and the x component of the weight are in the positive x direction. So those are the forces acting on M2. And we know the acceleration is in the direction of the tension. So this is the direction of the acceleration of M2. It's in the negative x direction. Alright, so now let's go ahead and apply Newton's law on M1 in the y direction, since there is no x direction forces on both M1 and M2. For M1, it's the sum of the forces in the y direction equal to M1 times A, and A here is in the negative y direction. It will be M2 times negative A. So now we replace the sum of the forces in the y direction by the two forces, which are the tension and M1g. It's the force of tension minus M1g, and we need to be really careful with the signs. If we assign certain direction to be positive, then the opposite direction should be negative. And here this is positive y, this is negative y, this is positive x, and this is negative x. So this is the left-hand side of Newton's law. So this is left-hand side of Newton's second law. Now the right-hand side will be m2 times a. Here a is negative, so this is basically minus m2a. And let's take this one to be equation 1. So we have equation 1 by applying Newton's law on m1. Now we need to apply Newton's law on m2, and in that case, of course, we need to apply it on the x direction and in the y direction, since there are force components in both axes. So if we start with the y component, so the sum of the forces in the y direction on m2 will be what? Will be 0, because the object is moving along the incline, it's not moving vertically. So the sum of the forces in the y direction on m2 is 0 in the y direction. So now let's go ahead and find the sum of the forces. That's the left-hand side of the equation. And we see that we have two forces acting on M2, as you see in this force body diagram, the normal force upward and the y component of the weight downward, mg cosine theta. So the normal force is in the positive y plus mg cosine theta, which is in the negative y. So we'll have negative sign here. This is equal to the mass times the acceleration, and since the acceleration is 0 in the y direction, so this is equal to 0. Now you can see from this equation, we can conclude that the normal force is equal to mg cosine theta. Alright, so this is the sum of the forces in the y direction. Now we'll take the sum of the forces on the x direction applied on M2. This will be equal to the mass M2 times the acceleration A, which is the same as the acceleration of M1, since the system is moving together as one entity. And now A is, as you see here for M2, A is in the negative x direction. So we'll have a negative sign here. We'll go ahead and analyze the left-hand side of Newton's law. So let's indicate here that this is left-hand side. We have two forces in the positive x direction and one force in the negative x direction. The two forces are the force of kinetic friction, the x component of the weight, which is mg sine theta, while in the negative x direction we have the force of tension applied on M2. So basically we have the force of tension, which is a negative value, plus the force of friction, kinetic friction in that case, plus mg sine theta, and this is equal to negative m2a. That's indicated here. This is the right hand side, and this is here also the right hand side of Newton's law. The equation of friction is the coefficient of friction times the normal force. If it's kinetic friction, then this is the coefficient of kinetic friction. And since we found the normal force here, if we call this equation equation 2, so from equation 2, we know that the normal force is mg cosine theta. Hence, you can say here from equation 2, we can write the force of friction to be equal to the coefficient of friction, and we replace the normal force by its formula from equation 2, which is mg cosine theta. Okay, so now we can take this value and plug it into this equation here. So I'm going to rewrite this equation, replacing the force of friction by this formula. So we have the force of tension plus replacing the normal force by equation 2. We need to remember that this is m2. This is equal to the right-hand side, which is negative m2a. And let's call this one equation 3. So you can see here we have equation 1, this one here, applied on m1. And we have equation 3 here, applied on m2. Notice here that the tension is a common denominator, so we can add those two equations and cancel the tension. Of course, the tension here is the same as this tension here. Those tensions are equal because it's the same strength. So if we add equation 1 to equation 3, and let me go ahead and remove this part here to make space. Now when we add two equations, we'll add the left-hand side of the first equation to the left-hand side of the second equation. And also we'll add the right-hand side of the first equation to the right-hand side of the second equation. So when we add the left-hand side of equation 1 to the left-hand side of equation 3, the force of tension will cancel out, because here we have positive force of tension, here we have negative one, they will cancel out, and you'll be left with the following. Okay, I just added this term to this term to this term. Those are the left-hand side. On the right-hand side, we have the negatives here, and we have m2a and m1a. So on this side, we have m1a minus m2a. Okay, now we can see here on the left-hand side, we have two terms that has m2. And then on the right-hand side, we have a term that has m2. The goal here is to find m2. So let's go ahead and try to collect all the terms that contains m2 on one side of the equation, while the other terms that do not include m2, we move it to the other side of the equation. So to do that, let's add m2a to both sides of the equation. This will cancel out m2a here and add m2a to this side. And we'll go ahead and add m1g to both sides of the equation. So this will cancel m1g from the left-hand side and add it to the right-hand side. So if we do that, you'll get uk times m2g cosine theta plus m2g sine theta plus m2a equal to m1g minus m1a. We have the terms that contain m2 on one side of the equation, while the terms that do not contain m2 on the other side. So now let's go ahead and take m2 as a common denominator on the left-hand side here. In order to isolate it, we'll take it as common denominator equal to, and here on this side, we can take m1 as common denominator if you want to. This will make things more organized. And now we'll go ahead and solve for m2. To solve for m2, of course, we can divide both sides of the equation by this term here. So that will end up with m2 on one side and everything else on the other side. So just divide everything by this long term here, and you'll be left with m2 equal to, in the numerator, you'll have m1 times g minus a. All right, so if we look at this equation here, all the terms are given. We know m1, which is 0.650 kilogram. G is 9.8 meter per second square. Acceleration is given to be 0.6 meter per second square. The coefficient of friction is given to be 0.250. The angle is 30 degrees, and so on. So all those terms are given to us. We'll go ahead and plug the values, and I would suggest to do it one calculation at a time so that you don't get error. So if you carry out the calculation, this will be 5.98 Newton for the numerator, while the denominator would be 7.62 meter per second square. The numerator will be Newton because you are multiplying mass in kilogram by acceleration in meter per second square. So this will give you Newton. While the denominator will be meter per second square because you're adding acceleration to acceleration to acceleration. Of course, sine the angle does not have unit. Cosine the angle and the coefficient of friction do not have units. So when you divide Newton by meter per second squared, the answer will be in kilogram. So you divide those two terms and you'll get the answer in kilogram. Now, if you're asked to find the tension, you can go back to either one of those equations, plug the values of M1 or M2, and you can solve for the tension. Actually, you can solve for the tension right now because we have M1, G, and A from equation 1. You can solve it directly without even the need to solve for M2. So we could have done that from the beginning. We could have just used equation number 3 to solve for M2 by finding the tension from equation 1 and then plugging it into equation 3 and solving for the tension. And the reason we took this long process because this helps you also to solve problems that ask you to find the acceleration. If you are given M1 and M2 and you don't know the acceleration, in that case you have to follow this process and solve for the acceleration. Alright, hopefully you found this video educational. Let me know if you have questions. Thank you.